Hello and welcome back to another episode. Today we are going to talk about the application layer of quantum mechanics, quantum technology. So using quantum to predict new materials in chemistry. If that sounds interesting to you, then as always, grab yourself something to drink and let's get started right away. In today's video, we are going to look at Quantistry. So here we are on their website as per usual. It says the future of materials engineered by design, the materials intelligence platform for industry. And the call to action is to contact them. Here we already see a couple of names running through. So for example, Osram, which is a big semiconductor manufacturer in Germany in the industry of LEDs. You see also Airbus here. And Daimler Trucks, so car manufacturing, airspace, defense, and many others. And there are also some which are blurred out. So they do already work with companies using their expertise, and we will learn a little bit more about what the expertise is right now. So it says, from prediction to industrial usage, the materials intelligence platform accelerating materials discovery and development. What if you could predict materials performance before making it? Quantistry makes that possible. Our AI for materials design and materials simulation software replaces guesswork with data-driven answers. From quantum chemistry modeling to alloy design and battery R&D, we cut testing costs and speed up innovation. I mean, the idea is very simple, so of course the execution is not, right? The idea is that you are basically using computers to do some experiments to predict certain materials with certain properties, to then kind of not having to synthesize them in the lab and then do some testing, right? And the applications that they are calling out here are on the chemistry side, so chemistry modeling. There's alloy design, so in the, let's say, metal industry, for specific applications, you need specific alloys of different metals. And then you also see the battery R&D here. So which of these 1,000 candidates is most likely to succeed is a question that they would, for example, answer if you give them specific material characteristics. How can we make our existing polymer 20% more heat resistant? So this is the first one is basically you give it a whole pool of materials and it picks the best one for your choice. This one is how can you improve the polymer? So this is basically taking an existing one and optimizing it towards something specific. And then the last one here is what is the most cost-effective way to achieve our target properties. So this is, let's say, looking very much at the, I guess, processing side of things, in the let's say synthesization process, right? So from bottleneck to breakthrough with our materials intelligence platform, Quantistry acts as an intelligent co-pilot for material science and engineers. It takes on the slow, complex and repetitive work of material simulation and analysis, giving your R&D team more time to innovate. And here's basically how it works. So you see a typical project which goes up to 30 days here. And now on the left side, it compares the traditional way that it's done, and on the right side, it's their approach. So let's go quickly through the traditional one. So let's say you want to have a specific material, or you have a specific hypothesis that some material could be well suited for your application. So you start with the hypothesis, you formulate that so you basically synthesize an idea into a hypothesis. Then you have here what they call the slow physical synthesis. So you're making this material, producing it. I don't know, you're using some oven to grow some crystal in there or something like that. Then you do some testing. So you are taking the material that you produced, you put it in some testing chambers, you use a microscope to look at its architecture, you might use X-ray to investigate whether the crystal that you have been trying to produce is actually the one that you have been producing. At the end, you might end up with a failure. You figure out that, okay, it's not exactly the material that I wanted to produce. So you come with the next idea. and do the same old story again. And then after 31 days, you might end up with a failure because your second test has also not been successful. Now, on the other side, here is what they are offering. They say they have this unlimited ideas and hypothesis start. So basically a whole pool of ideas or hypotheses. Then you select, then it selects for you parameters in minutes. So based on what your outcome is, or what the outcome that you want to have is, it selects those parameters. It optimizes, so optimized modeling in the cloud. So it runs on a cloud computer some simulation. So this is not necessarily a quantum computer, right? It says modeling in the cloud. And then you end up with your prediction and insights here. Validate the winner in the lab. So basically you are then taking this winning material, you synthesize it, and then you test it in the lab. And that should already be done according to them by day 9. So that's roughly where, like, usually in the normal cadence, you are still in the first round and you're taking your material. You're in the second round. No, in the first round. Yeah, you're in the first round and you take it usually then for the testing to the lab. And it says here with Quantistry, energy dynamics achieved, so 10 times more compositions evaluated and 80% less risk because of this computer-based approach. So then call to action, want to tap into quantum and AI power for materials R&D. And here again, let's say the proposals of the business case, so 96% reduction in testing costs with AI-based materials platform, then 10 times faster results through AI-powered materials prediction, and 3% less error rate across all types of materials. Materials intelligence that deliver results. We provide a powerful digital lab for materials to design and test innovation on a computer before you ever create them in the real world. So again, this is the proposal. You do the simulation in the cloud, and you don't do it in the real world. And this is delivered here as a service. So maybe also to take a step back on this, I guess it's not, let's say, on the first side, a completely new idea to do simulations of materials on computers. This is something that scientists have been doing for a while already, and that I guess big pharma R&D departments probably also already do. I'd be surprised if they would not have a unit for that. However, I think what might be a differentiator here is how this platform is also making it accessible to everyone, right? Because there might also be some small to medium-sized businesses that, I don't know, make magnets for very specific industrial applications, and they might not have access to this super big R&D department, so they might be interested in using such a platform here. Maybe magnets is not the ideal topic, but I mean, also magnets rely very much on quantum mechanics, so probably this is also something that could be interesting here, even though, like, from the target audience, I think it's more like battery research, chemistry simulations, the stuff that we've seen up above, right? Now let's hop back into what it says here. So define your challenge with AI for materials design. Easily input your design material properties or target challenge through our intuitive interface. Set your constraints and goals and let the platform handle the complexity. Let our materials intelligence platform do the work. Our AI engine determines the optimal computational pathway, orchestrating quantum mechanics, classical physics, and advanced ML/AI, so machine learning and AI models, to find the best candidates among millions of possibilities. And then here you see basically optimized and novel material candidates, validated insights, and clear performance predictions. Achieve actionable insights, not raw data. Get clear, validated prediction and data validations that guide your next R&D decision. We deliver answers you can act on, not just numbers. So that's also, I think, an important point. So basically, this is supposed to strip away all the simulation complexity, all the data science behind it. You basically just, I guess, through some graphical user interface, input your requirements, and you get out some actionable insights, and there is no such thing as data analysis required on your end anymore. And then, let's build the future of materials R&D together. There's again the call to action to contact them. Now, I think that was a good overview, but how does the platform actually work? And I guess we will learn more about that here. So how's the platform actually set up? Again, we see the proposals that we've seen before, like the let's say USPs, why to use their solution. And then here it explains a little bit more how the process actually works. So your path to breakthroughs in materials R&D in 3 steps. First step is define. So easily input your desired material properties to target challenge through our intuitive interface. Quantistry's platform supports candidate molecules, material simulation, and high-level R&D goals. So candidate molecules or material, target properties, and constraints. Like, I don't know, I don't have this, I don't know, I have an oven in the lab, but I can't use this and that, or and you can also put high-level goals like improve thermal stability, and I guess then somehow this string will be translated into the properties and constraints, probably more like the target properties that you want to have, and that kind of goes back into selecting the candidate molecules and materials and then running the simulation here. This is what it looks like, I guess the platform. So here we see recent workflows, active projects, compounds, workflows. So recently active projects, you see, for example, here polymers, what we've talked about before, right? But there's also battery materials and so on. So these are like the use cases that they are, let's say, considering, alloys and materials. And these are then kind of condensed into these workflows. So the workflow is, I guess, what is being executed on the cluster then, like, for example, a density of states calculation, a viscosity calculation, and whatever you might need in that regard. And then there is here a getting started section where I guess you can see tutorials and how to actually run something on the platform. It says our AI engine determines the optimal computational pathway, orchestrating quantum mechanics, classical physics, and advanced machine learning AI models to find the best candidates amongst millions of possibilities. And finally, there's the decide part, right? So now you have identified your problem, you have set up the workflow, the calculations are running, and now what you want to get back is the decision, right? Like, which material do I need to produce in my lab so that I can move on with my R&D work? And here it says receive clear validated insights and data visualizations that guide your next R&D decision, not just raw data. With materials property prediction and AI-powered prediction models, Quantistry delivers actionable results that reduce uncertainty and accelerate innovation in digital R&D. So optimize novel material candidates, validate insight, clear performance predictions. Powered by a uniquely intelligent materials intelligent mix. So there's the AI part, there's the physics-based validation, and the cloud-native accessibility as well. And then again, here are some use cases that we've seen before. So Airbus, Daimler, Osram, and there's also here the Bundeskriminalamt in Germany working on that, as well as other ones that are blurred, for example, from semiconductor industries, but battery research, energy, lubricants. We've also briefly seen that in the screenshot above, and there was also something about optics. Quickly about the company itself. As per usual, the future of materials engineered by design. Our mission is to empower the world's innovators to solve the biggest challenges in science and industry. We believe the path to a healthier, more sustainable future is built on a new generation of materials by moving R&D from slow physical labs to fast cloud-based material intelligence platform. We empower innovators with AI for material science and digital R&D, thus freeing them from bottlenecks and helping them create at the speed of thought. And then here are some numbers that describe the R&D efforts of the company. So more than 50% PhDs in computational chemistry, physics, and AI, 14 nationalities represented in the team, and 5+ patents from using their technology. A unique fusion of science and scale. Our team brings together world-class experts from the front lines of computational chemistry and material sciences, artificial intelligence, and enterprise-grade software engineering. And here we see the founder and CEO of the company and some let's say statement here. So it says, "Dear fellow innovators, as a chemistry student, I was mesmerized by the elegance of atomic interactions as the fundamental building blocks of everything around us. Then, as a PhD research scientist, I became closer to the practical outcomes of the field, but a frustrating reality became impossible to ignore. We are trying to solve 21st century problems with 19th century methods. I remember spending months trying to optimize a single solar cell absorber material, running endless simulations that would crash after a certain time, only to discover the predictions were off when we finally reached experimental validation. That moment crystallized a feeling that had been growing for years. The breaking moment. Materials development is fundamentally inadequate, yet the stakes have never been higher. Climate goals demand breakthrough materials for batteries, catalysts, and generators now, not in decades. Global supply chains have exposed how fragile our material dependencies really are. For the West, materials are no longer commodities, they are strategic assets where technology sovereignty begins. Yet, our approach to developing, optimizing, and validating these critical materials hasn't evolved much since Edison's trial and error days. Here's the crushing reality. At our current pace of materials discovery, 10 to 20 years from lab to market, we won't solve these challenges in time. For instance, the first lithium-ion battery took over 30 years from breakthrough to widespread adoption. However, we need next-generation materials for electrical vehicles and energy storage now, not in 2045. The solution is a physics-based AI, so the breakthrough came when we realized the power of combining quantum chemistry, classical physics, machine learning, and AI, generating thousands of high-fidelity predictions and finding patterns that would normally take decades to uncover. I realized we weren't just building another simulation tool. Rather, we were pioneering an entirely new offering category, a materials intelligence platform. Unlike traditional simulation tools that force you to choose between speed or accuracy, we could fuse physics-based methods with machine learning, AI, and cloud computing into validated prediction workflows that deliver both. We are not just making existing process faster, it's reimagining materials innovation entirely, thus resolving the real business challenges. When customers used our platform to accelerate their materials screening by 10 times to 100 times and file patents in months instead of years, I knew we were onto something transformative. Then, building the future, we are creating a world where everyone can design and validate revolutionary materials in weeks instead of years. We are where companies can develop breakthrough batteries without million-dollar labs, where the transformative materials essential to our sustainable future are created today. We are not just building a company, we are catalyzing a material renaissance. Everyone that gains access to our technology platform, every company that accelerates innovation, every sustainable material that researchers make faster, compounds into something far greater than individual discoveries. The future of materials is ready to be unblocked through our physics-based AI and delivered through our intelligent technology platform. The transformative materials of tomorrow don't have to wait. They can be created today. And then, of course, the call to action: join us in shaping the future of materials and building a more sustainable world through breakthrough innovation and then meet the founder. And here's again a little, let's say, timeline of the company. So the foundation was in 2019, back then as Quantum on Demand, QOD. Then in 2020, the first POC was delivered. In 2021, they rebranded. 2023, Quantistry Lab platform launched and begin proprietary synthetic material data generation. In 2024, so last year, I'm recording this in 2025, but end of 2025, it will probably be delivered to you in 2026. But in 2024, they reached this 3 million seed funding, and in 2025, first patents and co-filing with an enterprise customer. Now, why is this part of the hidden champions? Because technically it's not using, let's say, quantum technology in the first place, right? You see, it is, let's say, using classical compute, so very much AI technology in what we've been reading so far. Still, I think it's important for two reasons. One of them is if you're looking here at the partners, you not only see NVIDIA as, let's say, the typical GPU and AI supplier on the hardware side, but you also see that there is IQM listed here as one of the major quantum computing, let's say, powerhouses here in Europe, and probably a platform that is also being used by Quantistry, or at least planned to be used for what they are doing. And I think quantum computers might be actually a quite interesting platform in, let's say, possibly becoming like an API interface for this AI which is doing materials research. So the AI might be able to run some algorithms on the quantum computer, possibly even part of the AI could run on the quantum computer. I'm not sure if that is, let's say, a competitive solution already to running it on the GPUs. But for sure, the quantum computer could serve as some kind of ground truth to calculate certain very fundamental variables that are then being used by the AI models to run, let's say, higher level type of predictions. So that's the one side. The other side is, of course, materials research is still a very important topic when talking about quantum technologies. Let's say developing quantum sensors, developing quantum communication networks like fiber technology and stuff like that. But then also on top of that, the quantum computing, they all very much rely on those instruments. They need to have materials with very specific properties that might have not been manufactured so far, or where we might have not found a solution to produce them so far. And therefore, I think it's kind of interesting in both sides. It's a, let's say, two-sided leverage situation for quantum, and therefore I think it's a very interesting company in that context. And you also see here are some collaborations, IQM and Quantistry. Quantistry and IQM quantum computers announce MOQ to explore hybrid quantum solutions. So Quantistry and IQM quantum computers announce an MOQ, explore hybrid quantum solutions for the chemical and material industry. And there's, of course, more information available as well. With that, I would like to wrap up today's episode. If you found it interesting, don't forget to give this video a like. If you don't want to miss out on the next one, as always, make sure to stay subscribed or subscribe to this channel. And as always, stay hydrated and see you in the next one. Bye-bye.